Good morning, folks. I'm Dave Canterbury with Self-Reliance Outfitters in the Pathfinder School, and I'm back down here at the Pathfinder Outdoor Classroom this morning, where I just released 21 students from a navigation intensive class over the last 4 days. And we did most of what you can think of as far as navigation goes in that 4 days. We worked about 14 to 15 hours every day, including night exercises for navigation over land with both compass and map, and also solar and celestial navigation as well. So we cover a very wide range of topics in this class, and I encourage you to take it. You can find that class listed as Navigation Intensive at selfrelianceoutfitters.com. We taught the last class of that type for this year, this weekend. There'll be another one on the schedule in 2026 that you can check out, probably posted by September, okay? So one of the things that I want to talk to you about today is the main topic of this discussion was, I've done a couple videos lately on Lensatic type compasses, and I covered part of this in kind of a broad stroke in the video I did introducing you to the H3 Brunton compass, the Lensatic compass by Brunton International, okay? And we talked about how to plug bearings into this compass in low light conditions, or if you were traveling at night and you don't want to use things like headlights to figure out your azimuth in this compass, because it does have tritium, so it does glow in the dark, and there are certain aspects of this compass that you can see in the dark. You can reference that video from last week if you want to see those things, but we'll reference some of those pieces and parts in this video as well, and I'll cover them a little bit during the discussion. So the difference between a Lensatic compass and a base plate compass is the card inside the compass with degree readings on it is actually the same component that holds the magnetized and luminized north needle. So there's no independent bezel ring with degrees around it that you can manipulate to plug degrees into the top of the compass and then turn your body until the needle's in the doghouse to give you that direct azimuth or bearing. This compass is used a little differently. It's a direct read compass. So when you point it, the number at the top of the compass on that card is your travel bearing. And to put the needle in the doghouse, you rotate the luminous line over the luminous end of the needle, which is the north needle, which gives you needle in the doghouse. Again, you can reference that other video for that type of information. What I want to talk to you about today is a system that I've developed that makes this very quick and easy to put bearings into in low light or nighttime conditions. And one of the advantages to this style compass is that the bezel ring itself clicks when you move it. Each one of those clicks represents 3 degrees. So in the manuals for these compasses, what they basically tell you to do is start at the 0 line with your luminous line, and we'll talk about that in a minute. I'll show you an up close of that, and figure out what your azimuth is that you want to travel on, and then subtract that from 360, divide that value by 3 to convert it to clicks, and then move this luminous line X amount of clicks, either clockwise or counterclockwise, depending whether you're adding or subtracting. We'll talk about that in a minute. And then you have essentially, when you put the needle in the doghouse, you have essentially put that bearing at the top of your compass in the luminous area inside. That's a little bit much on information without showing you an example. So let's put this thing down on a table, and I'll kind of show you what I'm talking about. And then we're going to break loose from that, and I'm going to show you a much better system to be able to do this that I think will make it a lot faster for you, more enjoyable, more manageable, especially if you have limited vision, impaired vision, or limited light. Okay, stay with me. Okay, so as I said on this compass, you have a luminous line that moves when you move the bezel ring, and it clicks. You can hear it clicking. There's a clicker right there. Every one of those clicks is 3 degrees. You have a card inside that floats around, and it has mils at the top, and the red is degrees. And the luminous needle that's only glow in the dark on the north side floats as you move the compass inside independently of the bezel ring. So to achieve needle in the doghouse, you need to move this luminous line over the top of the luminous arrow, and you then have needle in the doghouse for travel. So if you're just shooting a normal bearing and you know what number you want, you can look at this luminous dial. You can point the compass in a north direction. You can move this luminous dial to the number of the bearing you choose to travel on, and then move the compass in your body until you have needle and doghouse and you're on that travel bearing. Just a little bit the opposite of a base plate compass. But in low light conditions, you're only going to be able to see this luminous arrow, the box underneath this front portion under the index line, because there's tritium in there. You'll be able to see this north needle, and those things will be visible at night, and you'll have east and west illuminated at night, and that's what you're going to be able to see. So you're relying a lot on these clicks to plug bearings in. So the theory behind this is, in all the manuals, whether it is Brunton or Kaminga, is that you start every bearing at the top at 360, and you subtract whatever bearing you want to take from 360. So let's make this really simple and say that we're going to go 10 degrees is our bearing that we're looking for, okay? Now, obviously, you're not going to be able to get 10 as far as clicks because it's in 3-degree increments. So you'll get 9, and you'll be within 1 degree of the reading you're looking for, which is closer than most base plate compasses will get you. And to do that, you're going to have to rotate this bezel ring either clockwise or counterclockwise, depending on what you're trying to do. And in this case, you can use the left add, right subtract acronym. And you know, if you want to go to 10 degrees, then you are adding to the front of this compass. So you would go 1, 2, 3. And when you put the needle in the doghouse at that point, you're going to be on that 10-degree azimuth, okay? Okay, so now let's say it's a bigger number. Let's say our degree reading we desire, starting at the top, is 120 degrees. That means we need to take that 120 degrees and divide it by 3, which gives us 40. Now we have to move this bezel ring 40 clicks, counting every click as we go until we get to 40, and then put the needle in the doghouse, and we will then have 140 at the top of the compass because the card will rotate where it's supposed to be. As long as the luminous line is lined up with the luminous needle, you'll get the number you desire at the top of the compass or in your direction of travel. To me, doing something like 40 clicks at night, it's very easy to lose track of that if you double click or something like that, or if your buddy is trying to give you direction, or if it's raining, or you're stressed out. 40 clicks is a lot. It's like trying to count paces, okay? When you're counting paces, you lose track quite often, many times, all right? Which is why I like using time sometimes better than paces, especially for the long distances. So let's look at a system we can use to shortcut this math and make it 15 clicks or less, no matter what the degree reading is. Okay, so if we understand that a 45-degree line on this compass is going to be 15 clicks, and we can break this compass up into 45-degree increments, then the most clicks we should ever have to take individually will be 15. Let me explain to you how that works, all right? If we break this compass up into 4 quadrants, 0 or 360 back to 270 west, 0 or 90 for east, 90 to 180 for south, or 180 to 270 for west. So we've got 4 separate quadrants here, and I've split those quadrants in half for a reason, and I'll show you that in a minute. So what I would do with this is, I would move a complete quadrant right off the bat if that's possible. To do that, we're going to use 3 different methodologies, and it really depends on what's easier for you to visualize in your head, because not everybody's brain looks at things the same way. So there's 3 different methods you can use. You can always use the left add, right subtract, as long as you remember that add and subtract is always coming from the top of the compass. You can't look at the bottom and go left, right. It has to be from here to go left, right, Because if you go here and you go left, right, then you're going to be changing the bezel ring in the opposite direction you would be here if you go left, because you're going to be going this way versus this way. So you have to think about that always from the top as far as left add, right subtract. I hope I'm not losing you. I'm trying to go slow. You can also look at that as counterclockwise or clockwise. So if I go counterclockwise, I'm going left and I'm adding. If I'm going clockwise, I'm going right and I'm subtracting. The other thing that you can do is what I do personally is look at that black bezel ring as if it has degrees on it, because I know what that looks like in my head. I understand what a protractor looks like. So if I know 360 is at the top and I know 270 is over here, I can move 270 to the top in one move by rotating that compass, because I know to get 270 to the top, I have to move one quadrant to the top. 90 degrees, boom. 270 is now at the top. If I wanted to go to 90 degrees, right, I know that I'm going to have to move the bezel ring the other direction to get 90 to the top, because 90 is over here. I've got to go like this to get it there, all right? I can visualize that in my head. When I get that concept down, now I can get within a quadrant of the number that I need. So let's back off the quadrants for a minute and look at a small example. Let's say that I want to go 10 degrees, all right? I want to go 10 degrees of azimuth from 0, like we did on the table. I know that to get this at the top of the compass, I have to go this direction to do that, which is what? Left add. I'm going from 0 to 10. It's also counterclockwise to add, so it's the same as left add. And it's also looking at the bezel ring in my mind and saying to move 10 to 0, I have to go this direction. Any of those will work. Any of them will force you to do the same action, okay? All right, so now let's use an example the other direction, like 340, okay? So if I want to move to 340 degrees, then I know I'm going to have to move this 340 to the top. Again, I'm going this direction, so I'm subtracting, right subtract from 360 to get 340, and I have to do that 20 degrees divided by 3. 6 gets me 18, 7 gets me 21, so 7 gets me within 1 degree. So I'm going to take this bezel ring and I'm going to get this 340 to the top by going 7 clicks, boom, 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 till I get that at the top, the 7th click. And then I know that 340 is going to be at the top of my compass when I put the needle in the doghouse. I won't physically see that 340 at the top of my compass because there's no numbers on the bezel ring. I'm seeing this in my head. And knowing that when I take my compass out and I put the needle in the doghouse or the luminous line over the luminous arrow, that 340 is going to be underneath the index line at the top of my compass, okay? But I didn't have to look at the compass necessarily to do that, other than to bring that luminous line straight up to the index line and then move the clicks. And I didn't have to look at it to do that, okay? So these are short distances. Now let's talk about something that's a little longer and why I think it's important to understand this quadrant method that I've come up with, okay? Let's say, for sake of purpose, that our azimuth is 120 degrees, all right? 120 degrees. If I'm going to go from 0 to 120, I'm going this direction to bring 120 up here. So I'm going left add. I'm adding from 0 to 120. I'm going counterclockwise to add. And if I look at the bezel ring in my head, I know that 120 is over here, and I need to go this direction to get it to the top, all right? The question is how many clicks? If I divide this by 3, I get 40. That means I've got to count 40 clicks to get to where I want to go, all right? But remember what I said earlier about this 90 and these quadrants, okay? If I know that in one move, I can see that luminous line and move it at a 90-degree angle to the top of my compass, even in low light, then I can make one move and get to 90. So I can just go boom, right? Left add, bam, and bring 90 straight to the top of that compass. Now I know I'm at 90. And I only have 30 degrees left, and they're additional degrees. I can take that 30 and divide it by 3, and now I only have to make 10 clicks, not 40, in that same direction in this example, because it's left add. I'm bringing 90 to the top. I want 120 to the top, so I bring 90 straight up, and then I go 10 more clicks, and 120 is going to be at the top of my compass when I put the luminous line under the luminous arrow, okay? So I just eliminated 3/4 of my clicks with one move. Now I've taken away the variability of having all of those clicks and doubling up by accident, losing track, losing count, because I only have to count to 10. And if you can break this up in 45s, you'll never have to count more than 15. So let's take another example going the other direction, okay? Let's say that our azimuth is 265, all right? The first thing I'm gonna do with that is I'm gonna take that 270 and put it at the top of my compass. And to do that, if I want 270 here, I have to do this. I have to go right, okay? Right subtract. I'm moving clockwise, and I'm imagining that bezel ring has 270s here, and I want it at the top, 270. So I took that one move and brought that whole quadrant over, and now I need to go 5 degrees less than 270. So I'm gonna subtract 5 degrees. 3 clicks will give me 6. And subtract is always right. Subtract is always clockwise. And if I imagine that bezel in my head, and I've got 270 here now, and I need 265, it's below this. So I go boom, 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 3 clicks clockwise, and I'm at 265 at the top of my compass. I line up my luminous line, my luminous arrow, boom, see you later. Now I reduced my clicks down to 3 clicks from what would have been, if I subtract 265 from 360, I'm at 95. 95 divided by 3 is 32. 32 clicks I would have had to make. I got it down to 3. One move in the quadrant and 3 clicks. That's the beauty of this quadrant method, the Pathfinder Quadrant method, okay? I have never seen this written anywhere. I'm not saying it's never been done. I'm saying there's no video on it, and I've never seen it written anywhere. If you look at the Kaminga manual, you look at the Brunton manual, you look at any manual that tells you how to use a Lensatic compass, none of them talk about this. They all talk about subtracting or adding from 360 and dividing that number out and making the clicks up to however many clicks you got to make in the 30s and 40s and stuff like that, okay? That's way too much variability for my engineering mind. I want the least amount of variability I can get. If I can make one move to a quadrant and then just go a few clicks one way or the other, that's exactly what I want to do. That's what this method allows you to do. But now let's go from this to the compass to show you how this works, okay? Okay, so I always start with the luminous line at the top of the compass over the black index line. No matter where my compass is pointing, that's the way I start, okay? Then I'm going to figure out where I want to move. In our first example that we used the long math on was the 120. Well, to get to 120 degrees, we first need to bring 90, which would be over here if this was a bezel ring, to the top. So we're just gonna make one move, go in this direction, and put a 90-degree angle right there, just like that. And now, when we move our compass so that we have needle in the doghouse, we're going to have 90 degrees at the top of the compass, okay? Kind of hard to see that, but I guarantee you that's at 90 degrees, okay? Now I know I've got 90, but I need 120. So again, I need to add 30 more, which is only 10 clicks. I made one giant move. and then I need to go 10 clicks. If 90 is at the top in my mind, and I need 120 at the top, then I'm going to go which direction, right? I'm adding degrees to the 90, and add is always going to be left or counterclockwise. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 clicks, I move that luminous line. And now, when I line this up on the luminous line to the arrow, you can see that my azimuth has shifted. We're going to be right on that 120 mark, okay? That's what we're looking for, with 10 clicks instead of 40 clicks. All right, so starting with our luminous line at the top, let's look at our example of 265, all right? 265. That is only 5 degrees off 270, which is a quadrant. So I can imagine in my head 270 is here and move this 90 degrees right off the bat, get a 90-degree angle between this luminous line and this index line. And now 270 in my head is at the top of my compass. Now I'm at 270, and all I have to do is subtract 2 clicks, and that will give me 6 degrees, and that will put me at 264, which is within 1 degree. So the direction I'm going to go, obviously, I am still subtracting, so I'm going right. So I go 1, 2 clicks, and now when I put the needle under the luminous line, I should be, I get this thing to work around this camera here, just off of a west heading, exactly right, okay? And when I lock it down and pick it up, I don't know if you can see that in the camera or not, but we're really close to that 265, okay? If you look in between these lines, and on that index line, you got 265 hanging right there, okay? So that just took us from going 32 clicks to going 2 clicks with 1 move in a quadrant, okay? All right, so there's a couple of examples to show you how easy that works and how simplistic it can be to use this Pathfinder Quadrant method for plugging in bearings in low light or low visibility conditions. Obviously, I can just put the luminous line to the top of the compass, make sure needle's in a doghouse facing north, move the luminous line over the degree reading on the card I want to travel to, and then move until the magnetic and luminous needle is underneath of the luminous line, and I'm going to be on the correct bearing. It's not so easy to do that in low light conditions, so the click method comes in very, very handy. It could also come in handy if you had bad vision and you lost glasses or something like that where you couldn't see the compass, but you could still make out the luminous line, the black index line, but you couldn't read the small numbers. You could go on faith that that was going to work by using this method, okay? I wanted to get that out there to you guys. We taught this method this weekend at the class. We used it extensively at this class for, I want to say, an entire day using Lensatic compasses and on a night exercise, and it worked out very well for people once they got it in their head and understood it. So again, left add, right subtract, or Lars. Clockwise, counterclockwise for add, subtract in your head, or imagining that bezel ring and the numbers on it to know where you need to move that bezel ring on those major quadrant moves. Very, very simplistic, okay? Just to give you an example down in here, if it's 186 degrees is my azimuth, right? We didn't do anything at the bottom. 186, if I could write here, 186. I'm gonna go straight to the bottom with that luminous line. And then what do I have to do? I have to add 6 degrees. So left add, clockwise, bezel ring image in my head. I've got 180 now at the top of my compass. Now I have 180 visually at the top of my compass, and I need 186. So this is gonna go down, this is gonna go up. So I need to go this direction, 3 more clicks to get that 186. Because if I go to the left, I'm adding. If I go counterclockwise, I'm adding. If I look at the bezel ring and I say this is 180, and it's going up this direction to the 360, if I move it this way, I'm adding 83, 86. So I just took that one fell swoop, double quadrant move, and turned it into 2 clicks. Very, very simple, okay? And again, it works the entire way around the compass like that. I proved that fact this weekend many, many times, okay? So listen, guys, I appreciate your support, and I appreciate everything that you do for our school, for our family, for our business. all our sponsor instructors, affiliates, and friends. Like I said, my schedule was absolutely slammed. I have 3 days off, and I have a wilderness first aid and a private event out here at the same time at the school. I have another 4 days off, and I have a Radio Made Easy event here at the school. I have another 3 days off. I have to prepare for a festival that we're going to, that the Pathfinder School is going to be featured at. I then have 3 days off again, and I have a basic class. 3 more days off, and I have a Bushcraft 101. So my schedule is bam, 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 bam. I'm trying to get as many videos up as I can, but I want to make them worthwhile, educational videos that you can put them in your toolbox and you're actually going to use the information. It's not simply entertainment for the sake of entertainment. It's teaching you something. Guys, I'll be back with another video as soon as I can. I really appreciate you. Thanks.